Let's do checkpoint 6.20. In this checkpoint, they want us to calculate the mass of the spring in the shape of a helix parameterized by R equals cosine t sine t, and our t values go from 0 to 6. And the density function for the spring is going to be given by rho is equal to x plus y plus z kilograms per meter. All right. So the mass in general for a wire or a curve is going to be given by the line integral over that curve C of the density function, and you could be in 2 dimensions or 3 dimensions, ds. All right, and so we have all that information, and we can just go ahead and plug the values in. This is ds without the arrow. This is a scalar function, so this is actually a scalar line integral. We have our parameterization. We just need our derivative. R prime of t is equal to minus sine t, cosine t, and 1. And we will need the magnitude in the case of a scalar line integral. So the magnitude of this vector will be the square root of sine squared t plus cosine squared t plus 1, which gives you 1 plus 1, which is going to be the square root of 2. So it's nice to have these constants here. There's probably not always going to be the case that it's going to be like that, but in this case it is. The mass now will be equal to the integral from 0 to 6 pi as given as limits. We have the x plus y plus z, but we're going to put in the x, the y, and the z from the parameterization. So that's simply the cosine of t plus sine of t plus t. That's the inside part. And then now the ds part is going to be the square root of 2 dt. All right, let's go ahead and integrate. Integral of cosine is sine. Integral of sine is negative cosine. And the integral antiderivative of t is 1/2. This should be a plus 1/2 t squared. And we're going to multiply everything by root 2, which is constant. Let's go ahead and take that outside, in front or in the back, doesn't matter. And we will evaluate this from 0 to pi or 6 pi. That's the square root of 2. And when we put 6 pi in there, we're going to get sine of 6 pi is 0. Sine of any even number times pi is 0. Cosine of an even number times pi is positive 1, but there's a negative in front. And we're going to have plus 1/2 6 pi quantity squared. So that's the first part, and then we're going to put 0 in. Sine of 0 is 0, but cosine of 0 is not 0. It's 1, and then that last one is going to be 0. All right. We will have a 1 plus 1, or negative 1 plus 1, which will contribute 0 again. And then all we have left is this. So that's 36. Half of 36 is 18. So this is 18, the square root of 2 times pi, and that's it. Nothing else happens. All right. So if you look carefully, it looks like the sine and the cosine did not actually contribute anything because the sine was 0 to begin with. Cosines canceled each other out. And if we look at this helix, as we go up, what is this? As we go up like 3 levels, the x and the y go positive and negative. So the x and the y go in the positive and negative direction, while the z goes straight up. So as the x and the y go in the positive and negative direction, they begin to cancel each other off as you go around that spiral. And at the end, it looks like the x and y components here did not contribute to anything because for some reason this thing seems to give a negative density when it goes in a negative direction. So I don't know if this is an accurate depiction of a density function that would give a negative value, but that's mathematically that's what's happening, and that's why we got some zero contributions from the sine and the cosine. All right, just a little side note, your final answer is here, 18 root 2 times pi. Okay, I hope that helps.